So let's talk about enzymes and what enzymes actually do. Enzymes are a type of protein, and remember if the breakdown of proteins, we talked about the 4 levels. There was primary, where it was just the amino acids put together. Secondary was when these guys they have little charges on them, and some are hydrophobic, some are hydrophilic, some have these little charges. So they start making these shapes, and they either make this spiral shape, which is called an alpha helix, or a zigzag shape, which is called a beta pleated sheet, and it kind of looks like a folded piece of paper. Those structures, when they're completed, they become this tertiary structure, and you can see it's a mixture of both. It's got some of the coils, the alpha helixes, and then it's got some of the zigzag ones. Those are the beta pleated sheets. You take a couple of these guys together and put them in the right direction, and they become this quaternary structure. And this is going to be, quaternary usually is 4, but this could be 18 pieces, this could be 12 pieces, or 2. And it's just, when you put these guys together, this is going to be the functional product. So an enzyme is one of these guys is a functional product, and they do a specific task in your body. And what does an enzyme do? They basically, let's concentrate on the black line first, and then we'll do the little dotted line next. The black line is showing the energy that's needed and time. And basically what's saying is there's a reaction that's occurring in your body, and without this enzyme, it's going to take a lot more energy and a lot more time to actually get done. Whereas if we have this thing called a catalyst, we call catalysts these specific proteins called enzymes. So if you've taken chemistry before and they talk about catalysts, there's something that basically gets the reaction to occur faster with less energy and less time. So enzymes acts as a catalyst in our body. And what they do is they make it so things happen faster with less energy quicker. So if we look at this dashed line now, you'll see number 1 that this dashed line represents the enzyme or catalyst. And you can see it required less energy and time to kind of knock out that same reaction. So if we need a reaction to occur fast, we're going to use an enzyme to do it. If we don't have an enzyme around or we can't make it for some reason, we're basically going to have to wait a longer time to get it done, and it'll cost us a lot more energy. So an enzyme is a catalyst that weakens a chemical bond, which basically makes something happen much quicker and faster. Each of these enzymes have a 3D shape, and it's called an active site. So basically it's one product that fits into this little pocket, and only that one product could fit into this pocket. So what happens is that this guy can only fit into this product. So let's name an enzyme and let's name a product, because there's a specific enzyme for every product. So let's say that this is the enzyme lactase, and then this is the sugar lactose. So if you have the ability to break down lactose sugars, what happens is the sugar is floating around in your small intestines. You make this enzyme called lactase, and that's the only thing that can fit in this enzyme. So what will happen is it'll go into that enzyme and break it into these 2 products. And the 2 products are going to be 2 different types of sugars your body can actually do something with. So an enzyme works by that specific thing binding to a specific site and then creating this thing called a product. An enzyme are specific for what they catalyze. So for instance, the enzyme that we just named, that catalase, or that lactase, can only do the sugar lactose. It can't do sucrose, it can't do fructose, it can't do any other thing except for that one item. And it's because the structure of lactose is so different from all the other sugars that it doesn't recognize them. And these items fit into each other. So like if this is the substrate and this is the enzyme, they fit together just like a lock and key. And if there's any mutation in one of these 2, it doesn't work. So you've probably heard that people are lactose intolerant. Well, what happens is, I'm just going to go back a slide. they have an enzyme that they're making every time they see the thing lactose, the sugar, but they have a little weird pattern right here. And because its structure isn't perfect, the function doesn't work. So when these guys come together, the substrate doesn't fit in. And because the substrate doesn't fit in, there's no product, which is the broken down sugars. And that's what we refer to as lactose intolerant, but we just know that they're making an enzyme incorrectly. So the structure of that enzyme isn't leading to the function, which is to break down that sugar, where if you're making a normal enzyme, you are making a good shaped enzyme, and every time it sees lactose, it fits in like this and breaks it down, and you don't have issues. When an enzyme is interacting with its substrate during a chemical reaction, they can refer to each other as an enzymatic substrate complex. So here's the enzyme, here's the substrate. Look how the pattern for these two are perfect. And if there was any deviation in either this or deviation in that, so this would be the substrate, let's say there was an extra bump, it wouldn't fit here. If this one had an extra bump, then this wouldn't fit, so there would be no product. So these two have to come together like a lock and key, and if that happens, if we had another slide right over here, another picture, you'd see a substrate. Enzymes are reusable. So when this enzyme will go ahead and take that substrate and make it into a product, it can do it again and again and again. So the enzyme doesn't break down in the reaction, it just gets used up until the body says we don't need you anymore, and basically it'll take that enzyme and recycle it and make it into something else. So these enzymes are like tiny little manufacturing machines. They're in our body. We make them when we need them, and they make reactions occur much more faster if they're there. But if they're not there, the reaction will still occur. It will just take a lot longer and take a lot more energy. Another thing with enzymes, most enzymes ends with a ASE. So we've talked about sugars ending with an OSE, so sucrose. So the enzyme that breaks down sucrose is, so sucrose is a sugar, and the enzyme that breaks down sucrose is sucrase. So anything with this ASE is referring that it's an enzyme. If you have the sugar lactose, your body is going to make lactase, ASE, that's the enzyme, and it's going to break that into products. And then maltase is going to be the enzyme that we make for maltose sugar. It doesn't have to just be sugars that we're talking about, but enzymes do a lot of different things in our body. And when we talk about respiration and metabolism, you're going to hear a whole bunch of different enzyme names, but they may or may not be linked to a sugar. So enzymes are important because all chemical reactions in biology needs enzymes to make these reactions occur, and they happen faster because of these enzymes. Without them, we would be really sluggish, and it would take a lot more energy and time to make these products. And then I'm going to talk about these guys in a few minutes in my next video.